Hello, I'm Eric Clausen, and I'm a geologist, and I'm going to be discussing in this presentation the Lake Champlain-Hudson River drainage divide. This drainage divide, like many drainage divides, is a feature that geologists, as a rule, do not like to discuss and they basically ignore it because they can't explain how it formed. At least they can't explain how it formed in using the accepted geological history interpretations. Well, we're going to look at the drainage divide in this talk, and we're going to note that it extends from the Adirondack Mountains in the west, where it's crossing some of the highest points in the Adirondack Mountains, and there's some deep valleys cut across the drainage divide, such as Indian Pass here. And then if we go to from New York State, from the Adirondack Mountains in New York State, across what I'm going to call the Great Valley to Vermont, and we get into the Green Mountains, where the drainage divide cuts across crosses the Vermont Valley between two high Green Mountain ridges, and that and between those, we have what I'm going to call the Great Valley, where it, where the floor is almost at sea level, and there's a canal that connects Lake Champlain with the Hudson River, and the boat here is at the highest point on the canal, which is 43 meters above sea level. Now, the Indian Pass here in the Adirondack Mountains in this valley is 864 meters above sea level, and the Vermont Valley here, where it crosses the drainage divide, has an elevation of 245 meters. And we're going to look at a number of other valleys. Now, each of these valleys that crosses the drainage divide extends from the drainage divide in a northward direction to the Lake Champlain Valley basin. And in a southward direction, these valleys extend sometimes with some twists and turns, as we'll see in a couple slides, that they all end up in the Hudson River Valley. So we're looking at a complex here of diverging and converging valleys, which cross the drainage divide. And these valleys must have been eroded at the same time, even though today the elevations of their floors are there's more than 800 meters of difference in those the elevation of the floors. Well, let's look at where this is. The red rectangle shows the region where we're going to be talking about. The Adirondack Mountains are over here. The Green Mountains in Vermont are over here. The Great Valley that I'm going to be talking about is this yellow strip that extends here. Lake Champlain is at the number 2. Now, the Great Valley extends north from Lake Champlain into the St. Lawrence River Valley. And Lake Champlain, which has a surface elevation of about 30 meters, it drains in a north direction into the St. Lawrence River. Um, and the Hudson River, it starts out in the Adirondack Mountains. We'll see in the next slide, it starts for a short distance as a southwest oriented river. Then it turns in a southeast direction, makes some twists and turns, and enters the Great Valley and continues down through the number 3 here. And it flows for quite a distance in the Great Valley before turning to cross what are now referred to as the Hudson Highlands to reach the New York City area and then empty into the Atlantic Ocean. So the drainage divide that we're looking at is here. Now, the Great Valley itself can be traced in a southwest direction all along the eastern part of the United States, where these numbers are. I'm not going to say too much about it, but that numerous other rivers follow short stretches of the Great Valley and then they turn and leave the Great Valley. So, and it's kind of a mystery in geology how the Great Valley formed. We're only going to look at this segment right in here in this talk. Now, I mentioned that we're talking of, this is a detailed map here of the region that we're going to be discussing. And I mentioned that we have diverging and converging valleys. Um, and if we look at the drainage divide, which is shown with the dashed red line here, the streams that go north from it, and I've shown the major streams here going north. In Vermont, it's Otter Creek and the Meadowee River. In New York and the Adirondacks, it's the east and the west branches of Ausable River. And you'll notice that all three of those um, end up in the Lake Champlain Basin. Now, to the south in the Adirondack Mountains, we have the Hudson River headwaters starting right at the drainage divide, and Boreas River, which is a Hudson River tributary starting at the drainage divide. And then the Hudson River kind of makes some loops here before it enters the Great Valley here and flows south. And to the south of the drainage divide in the Green Mountains, we have the east and west branches of Batten Kill Creek, Batten Kill, which is a drainage route which for a distance flows in the Vermont Valley before turning in a west direction to join the Hudson River. Now, the Vermont Valley continues south from Batten Kill, and if you trace it far enough south, it reaches into the Housatonic River Valley in Connecticut. Now, over here, I want to just point out that a major Hudson River tributary is the Mohawk River, which has cut a very deep valley and large valley between the Adirondack Mountains and the Catskill Mountains, which are to the south of the picture here. And I'm going to show you later on that just to the south of the Mohawk River are the headwaters for the Susquehanna River. So that will be part of the presentation when we get to it. Now, turning to the Vermont Valley, this map here was produced in the 1950s, and it has a contour interval. It's a topographic map with a contour interval of 100 feet. I'm going to use meters when I discuss the elevations of the passes here, but the Vermont Valley itself extends in a north-south direction here. We have a side valley that connects with the Vermont Valley that's going off in a northwest direction. And these two valleys join here just to the north of Manchester, Vermont. The red dashed line here is the Lake Champlain-Hudson River drainage divide. It comes to here where it ends because to the west of this line here, we have the Connecticut River drainage basin. So this is the end of the Lake Champlain-Hudson River drainage divide. Now to the north, in the Vermont Valley, to the north of the drainage divide, we have the headwaters for Otter Creek, which I showed you before. It flows in a north and northwest direction to enter Lake Champlain. And over here to the north of the drainage divide, we have the headwaters for the Meadowee River, which also flows north to reach the southern end of Lake Champlain. To the south of the drainage divide, we have the headwaters for the East Branch of Batten Kill, and over here we have the headwaters for the West Branch of Batten Kill. And as I showed you before, in the slide before, the Batten Kill flows south for a distance in the Vermont Valley, and then it turns west. It leaves the Vermont Valley and cuts across the uh, mountain ridges to reach the Hudson River. And looking at this, I just want to point out that if you were to ask the question, how were these valleys eroded? Uh, the most logical answer would be that we had two south-oriented rivers flowing, joining here, and because this is the kind of angle that you would expect south-oriented rivers to uh, um, make if they joined. And you might notice that the Medowee River starts as a south-oriented stream before turning in a northwest direction. Uh, and if this was eroded by south-oriented rivers, uh, what would have happened, why the drainage divide would exist in this region, would be as the Green Mountains were uplifted, eventually the rivers were unable to cut the valleys deeper, as deep as fast as the uplift was occurring, and eventually the uplift would outpace the ability of the rivers to erode the valley, and that would cause the drainage divide to form. That's a pretty simple answer, and if we just look at this area, I don't think anybody would argue with that interpretation. Now let's go to the west end of the drainage divide, and we're now in the high Adirondack Mountains. And this contour map has a contour interval of 10 meters. And Indian Pass, which you can see in the picture below, has the floor of the pass has an elevation of about 864 meters. And as we'll see, there's some other passes here, Caribou Pass, which is over 1,000 meters its floor, Avalanche Pass, which is comparable to Indian Pass in elevation, and then Lake Arnold Pass. And the dashed red line again shows the drainage divide. It's crossing some of the highest points in the Adirondack Mountains. It doesn't cross Mount Marcy, which is the highest point in the Adirondack Mountains, but it comes very close to crossing it. And some of these other mountains, Mount Marshall and Algonquin Peak and Mount Colden, all rank among the higher Adirondack mountain peaks. And what I want you to note here is that we have northeast-oriented streams flowing from the drainage divide. This one, it turns and then joins a northeast-oriented stream. And these northeast-oriented streams converge to form the west branch of the Au River, which then joins the east branch of Au River to form the Au River, which then flows to Lake Champlain. And if we look to the south of the drainage divide, we have a number of southwest-oriented streams starting, and these southwest-oriented streams, they converge to the south and west of this map section and form the headwaters of the Hudson River, which then, as you saw in the previously, that Hudson River, after flowing for a short distance in a southwest direction, turns in a southeast direction and eventually reaches the Great Valley. So again, we're looking at diverging and converging valleys. Now this, because of the elevations, and it's maybe not as clear cut as the Vermont Valley, but I don't think anybody would really argue if we just looked at this and we suggested that these valleys had been eroded by large amount of southwest-oriented water flowing across the region as the Adirondack Mountains were being uplifted, and that the water continued to cut valleys until the uplift uh, outpace the ability of these streams to erode the valleys, and the difference in elevation between the various passes represents the the routes that were first the timing of when the different routes were blocked by the uplift. Um, so if we just look at that, it's a fairly simple uh, description, but again, we're looking at just one segment of the drainage divide. Now, if we come east from there along the drainage divide, but not very far east, Mount Marcy is just off to the west, northwest of this map. Here's the drainage divide here, and we can see it's crossing two valleys here. This one is a much wider and deeper valley than this one. But most of the time, the drainage divide is up on the following the crest of the mountain ridges here. But these valleys, and I'm going to call this one Boreas Pass because it links the northeast oriented headwaters of the east branch of Sable River with the southwest oriented headwaters of the Boreas River. And remember, again, that the east branch of Sable River joins with the west branch of Sable River to form northeast oriented Sable River, which flows to Lake Champlain. And the Boreas River flows in a southwest direction to join the southeast-oriented Hudson River headwaters, with the water eventually ending up in the main Hudson River Valley in the uh, um, Great Valley. Now, just to summarize, and so you can visualize what we just looked at, we started out here in this black rectangle, looking at this map here, uh, and we saw the Vermont Valley, which at East Dorset, Vermont, where it crosses the drainage divide, and it had an elevation of 345 meters. We also saw where the drainage divide separates the Medowee River headwaters from the Batten Kill headwaters, and that had the valley floor there had an elevation of 300 meters. And as I was said, the Medowee and Otter Creek both end up in Lake Champlain. So they flow north. And the Batten Kill, you saw where the east and west branches come together. You didn't see where the Batten Kill turns in a west direction here, but on this map it shows this continue going west to the Hudson River. And as I told you, the Vermont Valley continues southward in Vermont. There are some other Hudson River tributaries that have uh, reached into it, but if we continue far enough south, we will get to the valley continues into the Housatonic River Valley, suggesting that at one time the water that flowed in the Vermont Valley did get flowed through Connecticut, not into the Hudson River. And if we look over here, we can see the west branch of Sable River and the east branch of Sable River, and that the west branch heads at Indian Pass and Caribou Pass and Avalanche Pass, whereas the East Branch heads at Boreas Pass, which has an elevation of 610 meters. Now, we're going to, after I come down here, and I want to show you evidence that the southwest oriented water that flowed across the Adirondacks probably flowed across also what is now the Mohawk River Valley down here. I'm going to show you that next, but then we will come over here and we will look at the Great Valley, which is the deepest valley that crosses the drainage divide. And it's, as I have mentioned, and I'll mention again, the elevation there at the highest point on the Champlain Canal is today 43 meters. Now, I've here we're south of the Mohawk River. The Mohawk River, you can see it in the northeast corner of the map here. And we're looking at a contour map. Again, this is an older contour map, and the contour lines are in feet, and it's a 100-foot contour line, if you're wondering about that. But the drainage divide between the Mohawk River and the Susquehanna River is shown with the red dashed line here. And what's important, and it may not be real obvious here, but there's a very steep slope from that drainage divide. It's sometimes referred to as an escarpment into the Mohawk River Valley, which is a significant valley, as you can see here. And then up above the drainage divide is almost right on the crest of that escarpment. And cut into that escarpment crest are the heads of a number of valleys here. One of them is Cherry Valley, which you can see a picture of here. And these valleys are the headwaters of various Susquehanna River tributaries. They flow in a south and southeast direction in to join the, southwest direction to join the southeast oriented Susquehanna River headwaters. So this is evidence that probably a lot of water once was flowing across what is now the Mohawk River Valley. And geologists since the early 1900s have discussed this in a number of research papers, published papers, that although nobody seems to have really wondered where the volumes of water came from that were necessary to erode all these different valleys. But it's commonly suggested that the Susquehanna River may have originated in the Adirondack Mountains. So the suggestion that the Mohawk River Valley was eroded headward across southwest-oriented water is nothing new. It's been proposed before. Now, coming to the Great Valley, which is between the Adirondack Mountains and the Green Mountains, here we've got the Adirondack Mountains over here, the Green Mountains. The contour interval here is again 100 feet, and the red dashed line here is showing the drainage divide between Lake Champlain and the Hudson River. And this is the Medowee River. We saw it earlier. It starts out almost in the Vermont Valley, and it comes up here to join the southern end of Lake Champlain near Whitehall, New York. And this is Lake George here. This is not part of Lake Champlain. Lake George has a higher elevation, although it does drain into Lake Champlain. But as you'll notice, there's a very deep valley connecting the Lake George Basin with the Hudson River Valley here. And if somebody was to build a dam up at the north end of Lake George, it wouldn't require much to cause Lake George to overflow into the Hudson River Valley south here. Now, the canal that I've been telling you about this is the Champlain Canal. which connects Lake Champlain, and the southern end of Lake Champlain is right about in here. Um, Although there's a South Bay here, uh, which extends between these ridges here, but the canal came around there to Whitehall because there was a lower route across those ridges uh, near Whitehall. Um, and this is the lowest route. And as I mentioned, the elevation here at the lock near Whitehall is 43 meters. Um, and Lake Champlain has an elevation of 30 meters above sea level. And the Hudson River down here where the canal leaves it is pretty close to sea level. Now, to summarize again, here we've got the area that we're looking at, and we've got these valleys that diverge from Lake Champlain. They cross the drainage divide, and then they converge again in the Hudson River Valley. This is a complex of diverging and converging valleys, and it's very hard to explain those valleys across the drainage divide unless they were all, erosion of those valleys all began at approximately the same time. Water doesn't flow uphill. And if you think about it, if the Great Valley, that valley here, which extends, and it's a big valley, as I showed you in the previous slide, that if that valley had been in existence, it would have, and the Vermont Valley had its present elevation, and these Adirondack valleys had their present elevation. It would have been impossible for water to flow from the Lake Champlain Basin across those passes in the Adirondack Mountains or across the valleys that we saw here in the Green Mountains. Um, and so, and there's really no way you can explain those all the valleys cutting across the drainage divide using water coming from the Lake Champlain area and flowing southward. And I think it was flowing southward not only because of the angle that we saw over here in the near Manchester, Vermont, where the two valleys come together, but also because of the evidence that probably we had large amounts of southwest-oriented water flowing down here, and that the Hudson River Valley probably eroded headward to capture that. And so what we're looking at is we're looking at probably an immense water source somewhere up here in the Lake Champlain Basin at a time when the Adirondack Mountains and the Green Mountains had not been uplifted and the Great Valleys had not been eroded, and that that as that water source, and had to be a tremendous water source because as the water was flowing across the mountains that were being uplifted, the water was able to cut deep valleys into the mountains before the uplift blocked the flow and to create what is today the drainage divide. Now, the type of water source that I can only imagine that would generate that volume of water would be a continental glacier that was melting, and probably the uplift would have been occurring as that continental ice sheet was present to the north of here, and it may have been even related to the presence of the continental ice sheet. And so that's my hypothesis for this, but It does not fit with the geologic history that is usually described for the region, and it doesn't fit with the glacial history also. So, and there are major timing problems because the mountains are usually thought to have been there before the ice sheets were there. Now, I'm going to conclude by just saying that if you want to look at more information about what I've discussed in this talk, I've written a paper titled Appalachian Great Valley Headward Erosion through the Lake Champlain Valley and its implications for New England ice sheet stagnation, New York, Vermont, USA, and Quebec, Canada. It's in the Journal of Geography and Geology, Volume 17, Number 2. It's a 1925 volume, a 2025 volume, and it's on pages 49 through 63. I've given you the link here, uh, and and I want to just mention that the Journal of Geography and Geology is open access, so there's no charge to see the article. I've also written a book in which I discuss the problem that geologists have because with topographic maps because they're ignoring pretty much all the drainage divide and other erosional landform evidence that's shown very well mapped on those maps, but that that book is titled The Topographic Map Mystery Geology's Unrecognized Paradigm Problem Revised Edition. And the book is available in at least some public and academic libraries and also from online booksellers. And I'm the author, and um, it was published by Authors Tranquility Press in Atlanta, Georgia. Okay, thank you. That's